So if you're building with generative AI, you've probably figured out that you're moving way beyond simple chatbots. You're giving your AI tools. You're letting it take action. I mean, you're building an agent, and that's a huge, huge leap. But what it also means is you've just graduated from managing one little component to operating a really complex distributed system. And that requires a totally different way of thinking about monitoring. So let's dive in and break this down.
And the difference is, well, it's night and day. A single call to a large language model, super simple. If it breaks, it throws an error. It fails loudly, it screams at you. But an AI agent? Oh, that's a different beast entirely. It can fail silently, get stuck in a loop, just burning through your API credits and your compute time, all while looking like it's working perfectly. This is the invisible enemy we're here to talk about.
This quote just hits the nail on the head. It's the core mindset shift you have to make. You're not just sending a prompt and getting a response anymore. No way. You are now operating a workflow where the AI is making a series of decisions, calling different tools and managing information over time. It's a chain of reasoning, and every single link in that chain is a place where it can all go wrong without making a sound.
All right, so here's our game plan for this explainer. First, we're going to talk about what it really means to go beyond the chatbot. Then we'll get into the new kinds of failures that pop up, what exactly we need to be watching, and the tools for the job. After that, we'll walk through a real-world production nightmare, a little ghost story, and then wrap it all up with the new mental model you're going to need to build these things reliably. Okay, let's kick things off with Section 1. The second you give an LLM a tool, I don't care if it's a simple calculator, a database function, or an API call, you're not just giving it superpowers. You are fundamentally rewiring the architecture and the entire behavior of your system.
All of a sudden, you've gone from a simple one-and-done process to a multi-step workflow. Your system is now state-dependent, meaning what it does in Step 3 depends entirely on what happened in Steps 1 and 2. And that right there, that's what opens the door to all those invisible failures and turns your simple app into this complex chain of reasoning that you have to be able to see into.
Which brings us right to Section 2 and this new kind of failure. With our old systems, logging was easy. It tells you if something broke. But in an agent system, every single piece can say, hey, I'm a success, and the whole workflow can still be completely, totally broken.
So, this is it. This is the one question your monitoring strategy has to answer. We're moving beyond just looking at the final output and saying, is it right? We have to be able to prove that every single intermediate decision, every step the AI took to get there, was also the right one.
So what does that really mean in practice? It means you have to be able to answer these questions specifically. Did it pick the right tool for the job? Did it feed that tool the right information in the right format? If things are slow, where's the bottleneck? And here are the big ones. Is it just stuck in a loop, going nowhere? And when it finally stopped, was it for a good reason, or did it just give up?
Okay, so how do we actually answer those questions? Well, that's what Section 3 is all about. The 4 critical signals you need to be observing. Think of these like the vital signs for your agent's brain, giving you a clear window into how it's thinking.
First up is tool selection accuracy, and the nuance here is absolutely key. An agent can pick the wrong tool, like using a hammer on a screw, and not actually trigger a technical error. The hammer might swing just fine, but the behavior is still dead wrong. This is a failure of reasoning, not a failure of code, and you have to be able to spot it.
Second, the arguments that get passed to the tools. And listen up, because this is where a huge number of silent failures are hiding out. The agent might correctly pick the refund customer tool, but then it passes in a mangled order ID, or just an empty reason. The tool call itself might not even crash. It might just fail gracefully. The agent retries, and you never see a thing, just a workflow that never completes.
Third is tool performance. Your agent is a sequential chain, right? One step after another. So a single slow tool, say an API that takes 2 seconds instead of 200 milliseconds, might get called over and over again in a single request. Agents are basically latency amplifiers. A tiny performance issue in one tool can easily snowball into a massive user-facing timeout.
And fourth, agent control flow. You must be able to see the sequence of steps. Is the agent actually making logical progress toward an answer, or is it just stuck calling the same tool with the same arguments again and again? These loops, they're the generative AI equivalent of infinite recursion, a silent, expensive, and system-breaking nightmare.
Okay, so we know what to look for. Now, in Section 4, let's talk about the how. What does the modern observability toolkit for an AI agent actually look like? What are the weapons we need? So the tooling landscape really splits into two main camps, and they work best when you use them together. First, you've got your agent-native platforms, like 𝗀𝗡, which are built from the ground up to visualize these crazy reasoning chains. And second, you've got your general observability tools, like OpenTelemetry and Datadog, which are absolutely essential for tracing what a tool actually does deep inside your infrastructure.
So, putting it all together, the perfect observability setup looks something like this. You start with agent tracing to see the high-level thought process. Then, you get really strict about your tool inputs, enforcing schemas to reject bad calls before they run. Then, you layer on distributed tracing to follow that call all the way through your backend. And finally, you analyze all that data, looking at the call graphs and tracking key metrics like how many retries it took.
Theory's great, but let's see how this stuff works in practice. In Section 5, we're going to walk through a real-world production incident, a true ghost story, where this exact approach was used to find and kill a bug that was completely invisible to every traditional monitoring tool.
Okay, so here's the scene. Customer refund requests are timing out left and right. The on-call engineering team is scrambling, but the logs are clean, not a single exception. The infrastructure dashboards all look green. CPU, memory, everything is fine. And the model itself hasn't been touched in weeks. It is, for all intents and purposes, a ghost in the machine.
But then, they look at the agent trace. On the left, you see what's supposed to happen. Search for the order, fetch the policy, call the refund API. Clean, logical, step-by-step. But the trace from the failing requests on the right, well, it tells a very different story. The agent calls search orders, and then it calls search orders again, and again. It's stuck in a loop until the whole thing just dies. The ghost is finally visible.
And the root cause? Get this. It wasn't a code bug. It was a language bug. The natural language description that told the agent what the search orders tool does was just a little bit ambiguous. The LLM misinterpreted it, thinking that same tool could also be used to process the refund. A one-line fix to a text description solved a massive production outage that logs would never ever have found. And that story just perfectly tees up our final section, the new mental model. To operate these agentic systems and not lose your mind, you have to graduate from thinking in isolated log lines to thinking in interconnected traces that show the entire journey of a request.
This quote right here is the single most important takeaway. Agents are distributed systems with cognition. Just like any distributed system, they have to coordinate a bunch of different services, your tools, to get something done. But they have this wild, unpredictable, non-deterministic brain at the center of it all, the LLM. You have to monitor the whole thing with the same rigor you'd apply to your most critical microservices. And at the end of the day, this changes the fundamental question we have to ask. In the old world of chatbots, success was all about prompt engineering. Did we ask the LLM the right question? But in the new world of agent engineering, success is about observability. Can we prove, step by step, that the AI actually did the right thing?
So I'll leave you with this final thought. Your AI isn't just a text generator anymore. It's an actor. It's making decisions and taking actions on your behalf inside your production systems. And with that new power comes a whole lot of new responsibility. So the critical question you have to ask yourself is, can you prove its decisions are the right ones? Thanks for tuning in.